We've all seen what modern AI can do, right? It's incredible. It can whip up poetry, it can write code, it can make these jaw-dropping images. But, and this is a big but, it has a huge flaw. It doesn't actually understand reality. It's just an expert at simulating language, which means it can be totally, confidently, and convincingly wrong. We call this the hallucination problem. So what if we could build an AI completely differently? An AI that models reality itself. One that gets the rules of the world, not just the words we use to describe it.
So here's our game plan. First, we're going to really dig into this hallucination problem and see why it happens. Then we'll explore this brand new architecture that builds what's called a world model. After that, we'll see how it stays creative, and the answer, believe it or not, comes from jazz. Then we get to the really mind-bending part, the deep link between information and physics. And finally, we'll see how this new engine for discovery is already making waves.
All right, so what's really going on here? Why does this happen? Well, today's AI models are basically just amazing prediction engines. Their whole job is to guess the next most likely word in a sentence. They're not designed to stop and check if that sentence actually makes sense in the real world. And that's the gap, right? The huge difference between sounding correct and being correct.
And this really shows two completely different philosophies. On the one hand, you've got what we have now, a world simulator. It's a master of mimicry, a pattern-matching genius that just creates this statistical echo of human language. But on the other hand, we have this radical new idea, a world model. This AI doesn't just mimic, it builds an actual logical map of reality inside itself, and every new thing it learns is checked against that map.
This quote just nails it, doesn't it? It's the perfect way to describe the situation. We use these tools because they're unbelievably powerful and fluent, but that tiny chance that it's just making things up, that fundamentally limits how much we can trust it when the stakes are high, in science or medicine or finance. We need an AI that isn't just well-spoken, but is actually rational. So how in the world do you build this? Well, the new architecture is called an Object-Oriented Large Language Model, or OO-LLM. Now that object-oriented part is the key. Instead of a big, messy cloud of data, it treats every single concept, a person, a place, a law of physics, as its own unique object, with clear rules and relationships. It's like creating this perfectly organized, structured garden of knowledge.
And this model organizes all that information into 3 layers. At the bottom, you have knowledge. This is just the raw data, the basic facts of what happened. The next layer up is physics, and this is really important. Physics here doesn't just mean EMC squared. It means all the rules of the world. Logic, sociology, psychology, you name it. It's the how and the why. And finally, all of that gets synthesized at the top into concepts, which gives it a really deep, abstract understanding.
Okay, so here's the really clever part. How does it figure out what's true? It uses a special measurement. The name is a bit of a mouthful, modified Shannon entropy, or RX, but you can just think of it as a reality check score. For any new piece of information, it asks a simple question. How likely is this, given everything I know about everything? A low score means, yep, this fits perfectly. A high score is a red flag, meaning something is really off.
Let's see how this works with a real example. Take this weird sentence. Alice, who is 100, and Bob, who is 20, are married and go to school daily. Okay, so the AI runs its checks. First, grammar. Looks fine, entropy is 0. Physics. Well, it's technically possible, so that's a 0 too. But then, logic check. Ding, ding, ding. A 100-year-old in school? Highly improbable. The entropy score shoots up. Then, the sociology check flags that age gap as a massive outlier. So, the system averages all those scores and says, whoa, this whole statement is highly uncertain. It doesn't just accept it, it flags it as strange.
Okay, so this all sounds great, but it brings up a really important question, right? If this AI is so structured and so obsessed with logical rules, can it ever be creative? Can it handle things that are fuzzy or ambiguous? Or is it just a really brittle calculator?
To figure this out, the designers had to look way outside the world of computer science, and they found their answer in a place that has mastered the art of balancing strict rules with pure, brilliant creativity for over 100 years. The answer is jazz. I mean, think about it. A great jazz musician knows all the rules, scales, chords, rhythm, but that structure doesn't trap them. It's the foundation that lets them improvise and create something totally new.
This AI uses that exact same principle. Its logical rules are the solid framework, but a flexible layer of tactics lets it improvise, adapt, and think creatively within those rules.
All right, now we're getting to the most profound, most mind-bending part of this entire idea. This is the core principle that connects this whole AI architecture to the way the universe itself actually works. This isn't just about building a smarter AI, it's about a whole new way of looking at reality.
And the principle is actually beautifully simple. In nature, things always seek stability. A ball rolls downhill to find its lowest energy state. A hot cup of coffee cools down to match the room's temperature. It's a universal drive. And this theory says that information works the exact same way. This leads to what's being called a master equation, and you can express it in two different ways. The information form says that a system always seeks maximum order, or minimum entropy. That's exactly what our AI is doing. And then there's the physics form, which is the famous principle of least action. The idea that physical systems always take the path that requires the least amount of energy.
And here it is. This is the big reveal. These aren't two different laws. They're two languages describing the exact same universal truth. The AI's hunt for informational consistency isn't just some random goal we programmed into it. It's a direct reflection of one of the most fundamental principles in all of physics. This AI works because it's built to work the way the universe works.
Now, that is a beautiful, elegant theory. But does it actually work in the real world? Let's see what happens when you take an AI built on this principle and you unleash it on one of the toughest problems in all of modern science.
The test case? Protein folding. The challenge is to predict the crazy, complex 3D shape a protein will fold into, just based on its DNA. Now, the traditional way to do this is with massive supercomputers trying to simulate all the physics. But the OO-LLM does something totally different. It just searches for the shape that is the most informationally stable. And the hypothesis is that this will be the exact same shape as the physically correct, lowest energy one.
So what were the results? Well, they're just incredible. In a direct head-to-head, the OO-LLM hit 99.9% accuracy in predicting the final protein structure. It didn't just match the state-of-the-art models, it actually surpassed them.
But it wasn't just more accurate, it completely shattered the speed records. By turning a brute force physics problem into a much smarter information problem, it was up to 20 times faster on the really complex proteins. That's not just an improvement, that's a total game changer.
And this might be the most revolutionary number of all. It got those amazing results while using only 4% of the energy of the other models. I mean, think about that for a second. This is a fundamental shift in how efficient and sustainable high-performance AI can be. But the real breakthrough, the thing that really changes everything, isn't just about the numbers. If you ask a current model why a protein folded a certain way, it's a black box. It can't tell you. But the OO-LLM, it can. It gives you a complete step-by-step report explaining the entire process based on its internal world model. For the very first time, we have an AI that's not just accurate, but is auditable, verifiable, and actually trustworthy.
And all of this leads us to one final, huge thought. We started this whole journey trying to build an AI that could model reality. But what we ended up with is a system that suggests reality itself might be a kind of computation. So it forces you to wonder, are we just describing the universe with information, or is the universe, at its deepest level, actually made of it?